Hi, I'm Sven. One more thing about metaheuristics. A heuristic is a pragmatic approach to solve a problem, which exploits our knowledge of the problem itself. But in math, we often talk about metaheuristics, which does not seem to be very problem-specific, but more meta. So today, let's have a look at metaheuristics and the key difference to regular heuristics. Welcome to Obtaino. Do you remember what a heuristic is? It's a rule of thumb to help us to find a solution for a very specific problem. Metaheuristics also provide a rule of thumb, but in contrast to regular heuristics, they are very generic and, interestingly, they work really good on a lot of problems. Assume we are climbing a hill on a foggy day, which is something we must totally avoid in real life. We want to reach the top, but we can't see the path, so we follow this rule of thumb. The steeper the climb, the higher we get. We know that if we cannot get any higher, that we have reached the top. This sounds very specific as well, but in fact, it can be applied to many problems other than hill climbing. The task when using metaheuristics is to apply different parts of it to the actual problem. In the case of the hill climbing metaheuristics, this means to think about two parts. Hill climbing uses the notion of steps that I need to take to make progress. A step means changing the decisions a tiny bit. We need to map this step to a slight update of our decisions in real life. Maybe this is a different time slot to produce an item in our factory. Maybe it's a different route I take to reach a destination. The second part we need to think about is going upwards. This is a metaphor to measure the quality of a decision. The higher I get, the better is my decision. So we need to map this quality to some characteristics of the decision we make. Maybe these are costs or carbon emissions. So if our actual problem contains ideas of changing a decision a tiny step and of measuring the quality of a decision, then we can apply the generic hill climbing rule to it. Sometimes there is no need to develop a dedicated heuristic to solve a problem. And mind you, hill climbing is just an example of a metaheuristic. There are several more, with ant colony optimization and simulated annealing as prominent examples that you probably have already heard of. See you next time and stay safe.